Good morning, everyone. I think we have a pretty house-full attendance here, so that's very good. Thanks for attending this session. It's Understanding the Lync 2013 Mobile Media Call Flows. I'm Kaushal Mehta. I've been with Microsoft for about four and a half years. My day-to-day role involves working with beta customers and working on their bugs, their feedback, and directly taking it to the product group. So this session is actually a direct result of working with the tab customers on 2013 mobile client, and it's a 400 level session, so it's going to be pretty deep. I'll let James introduce himself. He's one of our Lync MVPs from Malaysia.
Hi, good morning, everyone. My name is James. I'm actually a Lync MVP. I travel almost 28 hours just for this event. I'm actually serving in one of a company in Malaysia. So I've been in the industry for the past 8 to 9 years. And of course, like Gurdeep has actually shared, my first experience on Lync was on LCS 2003. So I think today there will be a so-called co-presentation between myself and Kaushal. We'll be sharing things on level 400, especially on the Lync Mobile. So Kaushal, back to you.
Thanks, James. The session objective, the main objective here is to understand the scenario with mobile users and troubleshoot it faster. So, and also the troubleshooting methodology that we can have, because the mobile scenarios, I mean, the user can come up with different symptoms or explain the scenario in a different way, but asking the right questions can actually help understand and troubleshoot the issue faster. We'll also be covering some of the limitations with media setup with 2013 mobile client. And the key takeaway from this session is going to be, we'll be covering like 6 scenarios, and for each scenario, we'll explain what exactly was there. So the agenda here is we'll be going through the mobility-related flags in 2013, few what happens when scenarios, and six specific scenarios, and then ending with the limitations. For Q&A, we would actually encourage a pretty interactive session. So if you have any questions, don't hold off till the end. Just stop by and you can ask it right away. So let's make it interactive and not wait till the end. So if you have any questions, just pause us anytime. The scope is a 400 level. So we are assuming that there is a basic SIP and SDP level of protocol understanding. SIP is the session initiation protocol, and SDP is the one that is actually used for exchanging the media candidates. We also assume some ICE candidate understanding, because that's used heavily for media candidates check and building up the final media candidates. We'll have a lot of diagrams and logs debugging, so we'll be doing live log debugging here. And the end goal with this session is actually faster troubleshooting. So if your day-to-day job actually doesn't involve looking at logs, ladder diagrams, or talking about protocols, then this session may not be for you, but it's a 400 level session. So with that, so the new media flags in 2013. So with 2013, we introduced the audio video support, like full VoIP, and on the server side, when you run this command, get CS mobility policy, you will see like there are many flags compared to how it used to look for Lync 2010. So there's the enable IP audio video. So this is like a global level setting to enable VoIP, and if it's set to false, then it won't enable the rest of the flags, even though if they are set. The next one is the require Wi-Fi for IP audio. So this is more to control the voice call for the users, and IP video. So require Wi-Fi means that if the user is not on Wi-Fi, then don't allow them to place audio or video, depending on the setting. Also, actually, if you look at this setting now in one of the recent Lync server CUs, you will see the require Wi-Fi for content, and that is for content sharing as well. So you can control how you want to have the users use content, whether it's going to be over Wi-Fi or whether you want to allow your users to use the content sharing in a meeting over cellular data. So those were the settings on the server side. On the client side, you will have you will have the setting look like this: require Wi-Fi for VoIP, require Wi-Fi for video, and mapping wise, like if this on the server side, the required Wi-Fi for IP audio actually maps to this one, Wi-Fi for VoIP, and Wi-Fi for IP video maps to video. So the text is a little different. So just to explain, that the text is not similar how it looks like on the server as compared to how the user would see it on the client. Now controlling these settings, so if the Lync admin has set both flags to false, and the user signs in to the client for the first time, this is how he will see the UI actually. So the VoIP is set to off because Wi-Fi for IP audio is actually set to false. And for video, on the users, on the client side, is actually set to on, just to give the user the experience of using video just for Wi-Fi to begin with. And then the user can control it. Because it's set to false on the server side, the user can actually change it on both audio as well as video. If video is set to true, then on the client side, this will be grayed out because the admin doesn't want a poor experience because the users, if they are roaming in like a 2G or a 3G cellular data, then there are chances that the video experience may not be good. So the Lync admin can set it to true, so that way the user cannot change it, and then complain about video quality calls to the IT admin. If audio is set to true and video is set to false, both flags are actually grayed out because if video is actually set to false, video is not just video. Video is actually audio plus video. So even if video is set to false, one would expect that this flag, this knob, would be actually not grayed out. But the fact that audio requires Wi-Fi and video is actually audio plus video, the RTP stream is actually audio plus video. That's why both are actually grayed out. And finally, if both are set to true, then it'll be grayed out for both settings. So this is just a quick brush up of those flags that are new in 2013. The media connection priority. So if the user has Wi-Fi as well as cellular data as well as obviously the PSTN on the mobile phone, the connection priority is always to use Wi-Fi first, provided the settings actually allow the user to use Wi-Fi. The next one is cellular data, it's 3G, 4G data, and then the fallback is always the call via work, which is the 2010 scenario, where the Lync server will place the call back to the user. Some of what happens when scenarios actually for mobility. Let's say the mobile user is actually roaming, and currently the user has both Wi-Fi as well as cellular data. So at this point, when you actually look at the log files from the mobile client, this is what you would see. It took me like 25, 30 minutes just to grab this line from the log file because the log files are not like very easy to read. I mean, they are like loaded with logs and information that sometimes it's not relevant to what we are actually looking for. So at this point, when the user has both Wi-Fi and cellular data, in the log file, you will see this network connection available equal to available, which means it has network connectivity for media, and then the network connection being used by the client is Wi-Fi. So for troubleshooting purposes, if you get the log file from the user, then you can quickly search on network connection available string, and you can at least do a sanity check as to what connection the user was. So this is just to help you save time if you are debugging the logs on the mobile side. Now, when the user moves to cellular data, you will see that in the log file, the connection is still available, but the network connection that is picked up is a cellular data network because there is no Wi-Fi, and between cellular data and PSTN fallback, it would say cellular data network. And of course, if there is no internet at all, then it will say unavailable and the network connection is none. At this point, the client won't be even able to sign in actually. So let's say the user is actually in a call and is in a network which has both Wi-Fi as well as cellular data available. In the log file, as shown in the previous slide, it will say the connection used is Wi-Fi. But if the user is roaming out of Wi-Fi at that point because the user is traveling or leaving the building, leaving work or leaving home, and is just in a cellular data network, then in the log file you will see cellular data network. But at this point, On the desktop side, if the mobile user is talking to a desktop user, then on the desktop side, it will say call failed due to network issues. And on the mobile side, it will say, I don't know if you can zoom in, but the call has ended due to connectivity issues, because currently the client doesn't have like seamless handover from one network to the other. That's one thing that we are tracking as part of the feedback from customers. So if you have any feedback on this, we can take it offline and we can talk about it. We are tracking this feedback in our with the product group. So this question actually came up on our internal Yammer, where I was actually looking for any other scenarios or something that the audience is looking for, and one of our internal folks actually asked about voice roaming users from. Zoom in. Oh, cool, thanks. Yeah, so reliability of many voice roaming users from Wi-Fi spot to Wi-Fi spot. So let's say in a building you have several Wi-Fi hotspots. So how should the IT admin actually configure or have quality policies, so that way the clients will have like good quality. Our recommendations right now is actually, follow the same white paper that we have for 2013 desktop client over Wi-Fi. So if you try to follow the same recommendations and set up your Aruba network, your endpoint or any other Wi-Fi endpoint in that way, it should still be applicable for the mobile clients. The media stack is pretty much the same actually, but again, mobile devices, the user can be using any like Android and like Samsung or Huawei or Apple or Nokia. So those devices, they have different processors. So our media stack is a little bit different to align with that processor, that chipset. So maybe we'll see some difference in performance. But if you have any specific observations that you have seen in your network, then let us know, and we can look at it. With this background, let's jump into the scenario one. Again, the goal of going through all the scenarios is actually to understand the troubleshooting methodology based on what the user is telling you, and isolate the scenario and do like faster troubleshooting. So scenario one, the symptom that the user is telling us is that they cannot place a voice call. Like not placing a voice call is actually a very generic statement. If I have to troubleshoot this, and if the customer is telling me, I cannot place a voice call. I mean, voice can be, a voice call can be anything. So first thing, to ask the user would be like, can you send us a screenshot? So, this is what actually I got from the customer. The call wasn't completed or has ended. Again, this is not that friendly message. This doesn't tell me what exactly happened with the call. So I'll start with the scenario analysis, and I'll ask whether it happened with just peer-to-peer voice or with PSTN calls, and that's what actually I asked the customer, the tap customer, because with P2P voice it would be a different call flow. PSTN calls would be different. From Lync mobile client perspective, if it's a P2P call, then it's not going through the MCU. If it's a PSTN call, then it's going through the mediation server. So it really depends on what exactly the voice call is about. And in this case, the customer came back and said it happens with any voice call, whether it's P2P voice call or whether it's a PSTN call. So that was yes for both. And then I asked, whether it's happening just with Windows Phone or iPhone, and this was happening with all mobile platforms, whether it was Windows Phone, iPhone, or Android in that case, or iPad. Asking the mobile platform is actually a little key here, because sometimes we see that with Android there is so much fragmentation that if they are using some Android device that has a different media or different chipset, then we see some media issues with that. But here it was all mobile platforms, so that wasn't that helpful. And then the next question is, this scenario is about the user not able to place call, place a voice call. But then, the question that I asked was whether he can place a call from a desktop client, and the same user using the same credentials same network was able to place call from the desktop and even to the same user that he was trying from the mobile client. So it was isolated just to the mobile client here. I asked for a test account from the customer, and I could repro from my Windows Phone 8 device as well. So my network was here in the US, and this customer actually was in EMEA. So it wasn't the network that was actually in the play here. This error notification actually, when I reproed it on my device, this notification comes right away. So there was no ringback. A ringback in a voice scenario will actually indicate that the call has been placed and there is some kind of notification from the server. But in this case, it was coming right away. And it didn't matter actually whether it's internal or external users. It was happening with both. Asking this question is also a key, because if it's external, then the call would be through the edge server, and there are more hops involved in the call path. But this was happening, independent of whether the user is internal or external. So the next step, was to actually come up with a ladder diagram to understand how the call actually flows in this case, or how the call is supposed to flow. So the mobile is the first point in the ladder diagram here, and the mobile client will always do HTTPS connection with the UCIVA. The mobile client doesn't do SIP directly for signaling. It talks with the UCIVA over HTTPS connection. And UCIVA is actually a component that's automatically, or it's installed on the front-end server. There is no extra configuration required for UCIVA. So UCIVA is on the front end, and then going by the scenario analysis, it didn't matter where, if the mobile user is calling another mobile user, or it's calling another PSTN user, or it's calling another mobile user, or another external user. So it doesn't matter what is there after front end in the ladder diagram. So I have edge, mediation server, Lync desktop, UCIVA, anything. It doesn't matter. So it would be flowing in this direction. And so when I started working on it, I expected that the error, or the cause is actually happening because of something from the far end. So this is what I actually started with. So my focus would be to actually grab the mobile log file and start analyzing it. So let me switch to my machine here. You see the screen? Okay, thanks. So this is the mobile log file when this actually call failed, and it's opened its snooper, and I'm in the messages tab here. As you can see, there are not enough messages here to actually see what happened with the call. The number I had dialed was this Chicago number, and if you look, it's actually just doing a people search. It didn't do anything with like placing a call, and the information here actually didn't help me either. So the way someone would actually start troubleshooting would, in Snooper would be, if you right click it, and if you go to nearest entry in trace viewer, what it would do is it would switch to the traces tab, and it would take me to the same timestamp actually. So here it's 13:38:12:877. It will try to take me to the same timestamp, so that way I can look at the messages around that. Now here I can start going up, because with voice call, things happen even before the call is being placed as far as media is concerned. So I would start, going through this log files, and then, of course, I'll start with the red ones here. And this one is actually a false. It didn't really help actually, because it's not related to media. As you can already see, the log file is not that easy to read, analyze. So start, and this was again a false positive for me. I couldn't actually find out. And then, so after scrolling up, what I also realized is this was actually related to my scenario here, this message. But then after talking with the devs and the test team, this code here doesn't really mean anything except that it says voice generic error. I was actually hoping that in the code, this would point to something helpful, but it didn't. So keep scrolling up, and then, so here is, keep scrolling up. So here it says initiate media call failed, media platform wrapper. So it does tell me that the voice call was supposed to be placed, but it failed with media call error here. And if I scroll up or scroll down, actually, again it says initialize media call failed, and here it says UCMP audio video modality, and here it says media platform wrapper. So at least we know that there is something wrong with the media call setup when the call was when the user was placing the call. So with this info, I'm going to switch back to the slide deck here. Switched? Yep. Okay. Fine. So logs analysis done. So again, coming back to the ladder diagram here, this is how initially we started. You know, that the call flow would be something like this. But the problem is that the mobile client is not even talking with the UCIVA as far as the voice call is concerned. So it's failing right on the mobile client itself. So I shared with the customer, you know, this errors. Of course, I took out a few things from here, but this is what we shared with the customer, as well as I worked with the product group on this and told them, you know, this is what we are seeing when the call is being placed. So one thing that we actually realized is after doing more debugging and going back and forth with the customer, this has to be some server-side setting that, you know, the client is grabbing, because from the same mobile device, if that mobile device uses my account, it was able to place a call. So it wasn't that the mobile device or the client doing anything. It has to be something that is there in the customer server environment that the client is grabbing, you know, while signing in or while placing the call. And that's causing the media initialization function to fail. So just when, you know, we were doing this and exchanging emails with the customer remembered that they had some custom port range configured. So since this was a tab customer, their environment is not like fully deployed and fully functional. So they were doing some QoS testing with changing the port ranges, and that's when they actually, you know, he reported that if you see the port range there is actually 57100, and then the and then the same thing for video port range. So that's not right, because if you have the port range so big, then your the client, the mobile client, will get the ranges which will be out of bound. It will go beyond 65,000. It would be like 114,000, something like that. So yeah, the desktop client actually somehow ignores this, but the mobile client doesn't like it, and that's why it chokes. And that's why we were seeing this. We have an open bug on this, and it should be fixed soon. But I mean, we don't see this with customer environment. I think I have seen just 3 customers hit so far, but the scenario was there to just explain, you know, how to like troubleshoot this and like the cause here. So, any questions on this scenario? How recent is this bug? This was reported when the client was in beta. So the Lync mobile clients were actually released for the first time, I think last year, February, around the Lync conference time, or I think March. So this was from February of last year. What we also have now is like checks, and you know, the engineers are familiar with it, and so it's actually out there. I mean, the engineers and customers, they know about it, I think. So, and usually we won't see the port ranges, you know, like misconfigured like this. The product group is aware of, you know, making changes to the set command, because when you set this flags, it should actually check for the ranges as well. So, you know, we are trying to attack this so that way we don't see this at all in other customer environments. So scenario 2. So first scenario was that user wasn't even able to place the call. Scenario 2 is, the symptom is user cannot connect an audio call. So it's able to place a call, but the call is not connecting. As you can see from the screenshot, it stays in the connecting state. So that's what the customer shared with me. It always stays in a connecting state. So again, starting with the scenario analysis, when I started working with the customer, after asking questions around, we came to know that it's only happening when calling the Polycom HDX 8000 endpoint. Again, this was I think last year, April, May timeframe, when there was some video interrupt testing going on with the tab customers. Was it happening with just Windows Phone trying to call Polycom, or was it all mobile platforms? So the response was that all mobile platforms, they were not able to connect the call with Polycom HDX endpoint. The same user with the same login, that is, would actually connect from desktop client. So desktop client connects fine with the Polycom, but not the mobile client. Again, I could repro from my Windows Phone 8 device using my login because Microsoft and Polycom are federated. So I was able to repro it. I was able to find the endpoint in the contact search, and I was able to place a call and repro the issue. The call always remains in connecting state. So it was able to place the call, meaning like you will hear the ring back. In the first scenario, there was no ring back as well. Here at least it was ringing back, but it always stayed in connecting. The call didn't connect. It was a federation scenario. So this is actually helpful to understand because federation scenarios are between edge to edge. So something to keep in mind if when we have to ask for logs or debug logs. Again, being a federation scenario, calling to other users from the same user account worked fine. So it was something to do with mobility, like Lync mobile client and the Polycom HDX endpoint. So back to ladder diagram here. The first point in the ladder diagram would be the mobile client because that's the caller placing the call. And then since it's a mobile client, the next hop in the ladder diagram has to be the UCIVA. UCIVA is on the front end. Since it's a federation scenario, it's front end talking with the edge because when the front end will see that the mobile client is placing a call to something like user@polycom.com and it's not able to find that address in its internal directory, it will ship the call out to the edge server. The edge will talk to Polycom's edge because federation involves two edge servers, of course, and we don't really care what's there after the Polycom's edge, whether it's front end, I mean, it will be front end, of course, but whether it's mediation server after the front end or any other device in the middle. But what we do care is the final after Polycom's edge, the call is actually hitting the HDX 8000. So this is how the flow is expected based on the scenario, and then since it's not connecting, we would expect that the error is coming from the HDX 8000, and then error or whatever is happening because of HDX 8000. So the first point actually to start troubleshooting is again the mobile client here. So I'll start with the mobility clients and let's switch. See?
Yep. Okay.
So I'll start with the messages here, and since the file is pretty big, I'll search for Polycom. And then, as you can see, again, the logs are filled with the search key Polycom. So I wasn't actually clear, like where to start this one. So I started changing it to trace here, and I switched to actually SDP. SDP is actually a string that it's part of the SIP call. So you will see the SIP signaling messages, and then below the SIP, you will see the SDP information. So this is more like from experience. When I'm troubleshooting this type of connectivity issue, I directly switch to SDP, Session Description Protocol. And then here, I see it is sending the request. So the mobile user is actually is sending its candidates. As you can see, it's doing both ICE 6 version as well as the ICE 19 version here. So the mobile client is advertising its candidates properly. If you look at all these candidates, it's the private IP, it is the NATed IP here, and then it also has the relay IP here, which is the edge server. The 131 is the edge here. So it is, when it's placing the call, it is sharing out its candidates. In the received response, which is coming to the mobile client, you will see that the SDP here, it has a private IP. So this is 172.31. It's a private IP of the HDX. And here, I don't see any candidates. So at least at this point, we know that the mobile client is getting a private IP in the O line here, but there's nothing in the candidates here. Ideally, you will see all the IPs here from Polycom side, so that way the mobile client can do media connectivity test and establish the final list. But there is nothing shown here. So the next question is whether the front end or the edge is stripping out some information before sending it to the mobile, or whether this information is coming directly from the Polycom side. So if I have to switch back to the ladder diagram here, my focus would change from mobile client to the edge, because edge will have not just the information from talking with front end, but it will also have information from talking with Polycom's edge. So that single file can actually give me more information. So I'll switch back and look at the edge. That's good. Yeah, good. I'll switch to the edge server logs here. So this invite is coming from the front end, from the mobile client, and then here it's going out to the Polycom. You can confirm this by looking at this PRIP. It says PLCM Polycom 5061. So that's Polycom's edge. So at least you know that this invite is going out to the Polycom. And then what I'll directly try to focus on is what response I'm getting from the Polycom endpoint. Because from the mobility clients, I did see that clearly that the Polycom endpoint is sending just a private IP in the O line, and there are no IPs. So let's try to see if I'll click on the invite here. So what this does is when I click on this one, and you see automatically all the other messages with the same call ID, they turn yellow. So it means that all these messages are part of the same call. Feel free to pause me if I'm assuming something and skipping any step here. So I'll scroll down. Okay, so this is the 200 OK. That's, again, you can confirm that it's coming from Polycom. And you can see that Polycom itself is actually sending the message this way. So it wasn't the Lync front end on our side or the edge that was stripping the information. It was the Polycom endpoint itself that was sending this bad SDP. But the cause doesn't stop here, because we don't still know that why the Polycom is not sending the IP addresses. So let me switch. Edge server log analysis done, outgoing invite. So just to recap, what I showed in the log file. So from mobile user, from the mobile client endpoint perspective, it is both Wi-Fi as well as 3G, but the preference would be for Wi-Fi. So it will advertise this IP address in the outgoing invite to the Polycom. It will also advertise its NATed IP, the 166 IP, which is for the Wi-Fi. And then it will have the turn server advertised as well, the 209 address. incoming, so we did that. Now for the incoming, so after 200 OK that came from the HDX, there was a private IP. So the way the media connectivity checks happen is as soon as the 200 OK comes to the mobile client, it will look at the IP addresses and it will start doing some media connectivity tests with its candidates against what's coming from the Polycom, from the far end. So then it's going to fail because there is nothing really that is coming in the SDP. So it's trying, but it's all failing. As you can see in the ladder diagram, the same user can actually connect from Lync desktop. So what we would actually do is I'll switch back to a scenario where I'm grabbing the edge server logs, but it's actually placed, the call is placed from a Lync desktop user, which works fine. So can you see it?
It's okay.
Yeah. So here you can see the invite is coming from the Lync desktop. You can confirm that using the user agent here. It says UCC API and 4517. And then I'll directly jump to the 200 OK because I'm very curious to see, how the Polycom sends its media candidates this time when it's being called from a Lync desktop client. As you can see, it's sending all its candidates this time. So to debug this type of issue, I have to actually know, why Polycom is sending it this time as against when the call is being placed from a mobile client. So there is something different with how the mobile client's invite goes out to the Polycom's edge as against how the invite goes out when it's coming from a Lync desktop client. So there has to be something different here in this invite that goes out to the Polycom's edge against the previous one, which was here. So after actually comparing the SDP and all these messages like line by line, let me switch to the, this is again the demo for the desktop client when it's placing the call to the Polycom endpoint. It's advertising all its 3 candidates. And from the Polycom side, we did this. The Polycom is actually sending the relay as well as the host address. And when the desktop client gets a 200 OK, it will do the connectivity tests. This one will fail because the 10 IP can reach the 140 IP, but the 140 IP cannot reach this. So this test will fail for the final candidate list. This one will work because both are public IPs, and assuming the port ranges are open on either side, this one will work fine. So the preference is always for the host address to, for the host addresses to talk first, then it's a NAT, and the final option is, the final preference is for the edge. So it's for host first because if it's in the same network, then we don't want the audio, video, the RTP traffic to traverse through NAT or edge. So this is the desktop scenario though. And we did the analysis here, and we did see that it was different. I mean, the invites are similar in terms of candidates. If you look at both the invites, I did notice that there were different codecs when it was when it was a mobile client placing the call as against the desktop client. But since there is no 415, 415 is a SIP response for media-related failure, and 488 is again media-related failure. But I didn't see 415 or 488 coming from Polycom. So the codec wasn't an issue here. Like codec negotiation wasn't an issue here. What I did notice was that mobile client didn't offer this string in the SDP. This is actually something we added for interoperability, and this wasn't there in the mobile client's SDP when it was doing the I6 advertising. So back then, actually, Polycom and our Lync PG, we were looking into this video interrupt scenario. But if you test this scenario today, it's actually fixed because the mobile client is sending the MS proxy that string actually. So Polycom's endpoint, it might have like some kind of customization to look for this string when it's sending out the candidates. So because it didn't see this content disposition MS proxy 2007 fallback, it somehow choked. So it was still an issue on our side. We fixed it, and it's working now. So, any questions on scenario 2? Yeah.
What did you use to compare the two insights? Do you use diff, or do you have any kind of tool that does that, or just visual?
It was visual. It was visual. Yeah. It's I've thought about coming up with tool or doing something, but the fastest one is just snap like Notepad or copy paste the SDP into Notepad file, snap the two Notepad files, and just go through it line by line. Usually it's the same number of lines, so it's a little easy to compare. But yeah, we don't have any tools, or I haven't even seen any open source tools or anything on that one. Yeah, it's usual. It's all visual. Back in the days, I used to use some kind of diff command, but if there are line breaks or if something changes, then it will say like the full file is different, right? So yeah, it's visual. Yeah. Okay. So scenario 1 was the user wasn't even able to place a call. Scenario 2 was the user was able to place a call, but the call didn't connect. The scenario 3 is the symptom was that my wife was complaining that she was placing a video call, but it was getting connected with audio only. So on her side, when she's placing a video call directly, on my side, it was just connecting with audio. So you can see how the discussion can go, right? On her side, it was saying that video was not accepted. So as a user, the user will think that the other user is purposely not accepting the video. So so let's see. On my side, as you can see here, it says this was a video call invite, but since I don't have a Wi-Fi connection, we just connected audio. So what I noticed, when I saw this is I told that I didn't have Wi-Fi. I was on the road, and there was just cellular data, and my setting was require Wi-Fi for audio set to true. So it won't connect me if I am not on Wi-Fi. So for video, that is. For audio, it will connect. So it will still connect the call, but it will just connect the audio stream of it. She will again, tells me that video call got connected with audio only, even after I told, that's not Wi-Fi. So my response was always, like, I'm not really sure. So the second scenario within this was actually when I didn't even get the notification. So sometimes I got it, and for some other scenarios I didn't get it. So I was very curious to see, why I'm getting it, when I'm not in Wi-Fi. But for some scenarios, why I'm still not getting any notification. So analyzing this, as you can see, like for video, the required Wi-Fi is set to on. So at least I know on my side, when the notification comes about Wi-Fi, I know exactly why the video call didn't connect. And when she's calling, this is how I was seeing the toast show up on my phone. And this was what I got when there was no Wi-Fi connection. But in some other scenarios, when the toast showed up this way, this is what actually happened. I didn't get any notification, and just the audio piece connected. So as you can see here, if I have to compare both toasts, there's nothing that is different actually. So from end user perspective, when you are troubleshooting this type of scenarios, I mean, the user will still say, it's the same toast that is coming up, same UI. So why the experience is different, why the notification doesn't come up. So I started troubleshooting this, and she was using Lync desktop, and it was a federation scenario here. So when it's Lync desktop, the next hop in a federation would be the edge. And the edge is, actually the edge is talking to the front end in every scenario. So whenever you're looking at edge, it would be talking to another edge or another user, or it would be talking to front end. Since I was on mobile, the front end will talk to the UCIVA, and UCIVA would do HTTPS to my side. So it's SIP from desktop to edge to front end, it's SIP, front end to UCIVA. So UCIVA is a component on the front end itself, and UCIVA is doing HTTPS connection to my mobile client. The response will come through, and this is how the call would connect. For this type of scenarios where you have edge, it's best to actually start with the edge logs here to see exactly if you can find something. So I'm going to switch to my edge logs here. Okay, good. So in the edge logs here, as you can see, I hope you can see fine.
Yeah, it's okay.
The invite is coming from the desktop user. It says the peer here, and you can look at the from header that says the username, and then it goes out to the front end, as we saw in the ladder diagram here. What I really noticed after that is there is this message header with push@push.lync.com. So my whole thought process changed at this point, because as soon as you see the message header with push@push.lync.com, I realized that somehow the push notification service is coming into picture here. As you can see, it's going out to the Lync Online world. So in the ladder diagram, there was no Lync Online. But from the logs, it looks like it's trying to reach out to Lync Online first before my mobile is being contacted. So let's switch to the ladder diagram. So we had Lync Desktop, Edge, Frontend, Usiva, Lync Mobile, and this is how I thought that it would actually work. SIP, Frontend, Usiva, Lync Mobile. But what was happening, as soon as I saw those messages, those SIP messages lines, I realized, somehow the push notification service is coming into picture. So my Lync Mobile wasn't actually awake. It was actually running in the background. So you can see in the ladder diagram, the UCY is continuously trying to wake up or reach out to the mobile client. It's not able to contact, and that's when the front end will realize that it's not able to contact the mobile client directly. So it will ship out a SIP message to the Edge server, and Edge server will ship it out to the pinch, which is the push notification clearinghouse. That's behind the Lync Online. So the Lync Online push notification clearinghouse will do a Windows Phone notification call to the Lync Mobile, and that's how the mobile client will actually wake up. It will do a 200 OK, and then finally we'll see that the mobile client is able to respond to Usiva. So this scenario actually tells us that the fact that, so now I realize that the difference between the two scenarios was that when I got the notification, my Lync app was running in foreground. When I had no notification, the Lync app was running in the background. So because of that difference, the notification doesn't show up when the app is actually woken up from sleep or from background. So after this, the same. So this is the media call flow for this, but it's similar. So once it's connected, the media will flow from Lync desktop client to the Edge, and then Edge to the mobile client, and so it all went through the Edge. But the whole purpose of this scenario was to help understand your users, your end users may come up with some different scenarios, so troubleshooting and coming up with the right thought processes sometimes actually helps, and try to nail down, because this was actually very tough to understand in the beginning why the notification is not coming out. Any questions on scenario 2, on scenario 3? Is that a bug? It's a bug with how the client actually gets the notification from the Lync Online. Yeah, it's a limitation right now for this. Yeah, we are aware of it. Because ideally, we would like to see the notification no matter what, right? But what happens is the logic that is there to display the notification or to pass on the information to the Lync Online, I mean, it doesn't have extra area or extra space in the code to tell Lync Online or the client that it's not connected to Wi-Fi. So because of that, the notification doesn't come up. So yeah, the idea behind this scenario was to compare similar scenarios and then see why the notification doesn't come up, and why a video call can actually connect just as an audio call. It's still media related, but it's a problem in the signaling. It's nothing to do with actually media here. Yeah. Any other questions? Yep.
So same scenario, but you have an IM. So essentially users sign in on the Lync phone, sign in into the mobile client, running in the back. Someone on the client goes and sends an IM, and because it's running in the background, they don't get it. So it bounces back to the person sending the message saying, message not working. They put an help desk ticket saying, like you broke, it's not working. But we know that the message will be able to read it.
So that scenario, so the question is, it's an IM scenario. Desktop user is sending an IM to the mobile client. The mobile client is running in background, and it didn't get any notification, right? So the person who is sending the message will get a failure. The way to troubleshoot this would be to look at your edge server logs, and on the edge server, you should actually see that message. I'll quickly switch here. See?
Yep, it's okay.
So you should see this messages on your side as well, because this message, this zip message, is for push notification, and it doesn't matter whether it's audio, video, or IM. This should actually go out to Lync Online. If it's going out to Lync Online in your case, and you still don't see that message coming on your Windows phone, it means that something's wrong with the app or the connection between Lync Online and push notification service. And we have seen issues sometimes, with push notification services where it's not sending out messages to the client. So, yeah, but for that one, you have to start with edge server and make sure that at least the front end is sending it out to the edge, and edge is sending out to the Lync Online. That will at least. Sorry. So for that, actually, we have to first confirm that the edge is sending it out, and still the client is not coming up. After that, we have to work with the Lync Online operations, and then they'll investigate. We'll have to repro it again. They'll collect the logs. Yeah, it's an on-prem plus online scenario at that point. It's more like a hybrid type of thing to do. Yeah. Any other questions on scenario 3? So I'll hand over to James for scenario 4, 5, and 6.
So thank you, Kaushal. So I think for the past 3 scenarios, I believe everyone is still trying to digest the contents that's been given for Kaushal. So before I actually begin my scenario 4, 5, and 6, 4 and 5 will be a working scenario. So I think let's not be too stressed out for your brain. And scenario 6 will be an actual scenario where I actually ran a POC for the customers. So before I actually begin my session or contents over here, let me see a few hands who are actually partners who are actually deploying for customers. Can I see a few hands? Oh, that's a lot. Okay, so for customers who are already implemented on Lync, who is actually still on Lync 2010? Oh, time to upgrade, sir. Time to upgrade. Okay, so I think mostly or everyone are on Lync 2013. I don't want to see fingers crossed behind, I'm on Lync 2013. Oh, okay. Okay, great. So I think everyone has actually, who hasn't went for a keynote earlier? I believe everyone has, right? So Gandhi has actually shared the so-called upcoming features released on Android. So I think there was no reason to actually go for Lync Mobile. So I think what I'll actually be covering on scenario 4 and 5, 6 will be something that probably for customers as well as partners that you may want to take note of. So on scenario 4, basically call flow, okay, for mobile users making to a PSTN. Okay, so in most cases, I think for such a troubleshooting, sorry that I have not covered this slightly earlier. So just to give you an insight, in troubleshooting for Lync Mobile, apart from OCS Logger, okay, your snooper, you may want to also turn your debugging on your Lync Mobile. So who knows where to actually enable the Lync Mobile? Logs. Has anyone tried before? So great. So for those who are not aware, so where you can actually enable it, right before you actually sign in to your Lync Mobile, there's a small little option button at the bottom, okay, or click on Advanced. There is a Lync Client Log sign-in logs. Okay, just turn that on and produce your troubleshooting steps. Once it's complete, send the log files back to yourself. Send it back to yourself. Okay, it happens on your Android, on your iPhone, as well as your Windows Mobile. Okay, so once you have all these logs, okay, before you actually dig in all these logs, because for me, times may be confusing as well. So once I have all those logs, I have a Lync mobile log, I have my front-end log, my age, sometimes my mediation. Okay, things may be a little bit confusing, or to add things worse, I will need to even look at my media gateway. Okay, so before you actually start all this, try to actually illustrate the diagram that what Kaushal and myself will be presenting. So you draw simple lines and put up the components that is involved in here. So for a mobile calling PSTN, okay, you have a Lync mobile client, you have your UCWA services, your front end, your mediation, okay, and if you are using SIP trunking, you will have your SIP trunk, or you have a PSTN or media gateway, and last but not least, your final destination number, okay. So are you still guys with me? Good? Cool. Okay. So calls happens through HTTPS to UCWA, and it happens through SIP invite from your front end all the way to the number. Okay? And you should be expecting a SIP 200 OK from your caller. So you will have an alert first, going all the way to your Lync mobile, and there you go. Some connectivity over here. Okay, so sounds simple, great. So my recommendation along the field, try to always gather a log files, which is a working one. So when you go actually on the field to another customers, for partners or customers, probably before you make any changes, you always have a comparison, okay? So I'll bring up the logs. Channel 4, is it? Oh, sorry. Yeah, okay. So if you notice, that would be, using the OCS logger. So basically, once you have actually triggered a number, and I'm actually calling a number called +1-800, followed by the numbers behind. And basically, what usually I would do on a log gathering, I will usually record down the number, okay, or even myself that will be making the call. So you can actually streamline, and you can actually narrow it down. So if you notice that OCS logger is a fantastic tool, I will always recommend that you install it on at least on your Surface or your tablet, that you can actually monitor files probably on a run as well. It will eventually tells you that there is an invite coming from where, and these are the destinations. So if you notice, I have an IP, private IP over here, 38.124, going down all the way. Oops. Okay, and it's actually going through on my Lync mobile. So where's the next private IP? Okay, here you go. So this is basically the contents that you are actually trying to actually initiate. And if you notice, there will be also the codec G.72, sirens, okay, what are the type of bit rates that you actually want to initiate with your callee. So if I scroll down, and you notice that there will be a call trying, okay, that is trying to actually return on the from the PSTN side. So scrolling down. Oops. You have an acknowledgement from the mediation, and the process goes on, and you will actually get a call that will be established. Oops, not here. Okay. Nope. It should be on top. Oh, okay. Okay, thanks. So if you notice that the candidate, okay, or the endpoint that is actually trying to establish, these are the actually call flows that it goes through. So you have a SIP traffic, which is a SIP trunk IP, which is 209, okay, and it's actually trying to relay your address or the signal actually out to the outbound call as well. Okay, so going back to the slides. So this is actually how the process flows. So you have your log files, you have your slice and dice lines. Okay, next is to have an illustration on it. So let me just pull out. So you have all the IP addresses of your Lync mobile, where is it sitting behind, okay, and what are your mediation servers all about. So most of the times users are actually roaming outside, okay. You may be connecting from a GSM network, or probably you're connecting from home or somewhere else, Starbucks for instance. So for this case, we are actually connecting through behind a firewall, and I have a private IP address of 10.1.206.79, and this will be my NAT IP address. So I will be initiating a Lync invite, a SIP invite, and peer-to-peer is actually not supported, and I will actually need to go through the firewall or the public IP, reaching through the edge. Okay, so the edge, once you have actually reached to my mediation, okay, there will be a alert of 183 from the mediation sending across. Let me just pull it out. Oops. Okay.
So the mediation server is actually.
Okay.
So the 183 from mediation that comes in, it actually is telling the caller that. Oops.
Okay.
Sorry. Yes. So the 183 that's coming from the mediation server, it's telling the caller that the caller can reach the mediation directly on this IP or on its public NAT IP, or it can go through the edge. So mediation is just like any other user in this case.
Okay.
Yeah, and in this case, what we had is the edge server was actually NATed. So you can see the IPv4 address is 254, and then the NAT enabled is 209. So the communication is happening from mediation perspective. The communication is happening between the external NIC and edge's external NIC. So it's not going out to the public. It's still staying internal. And if you see, the connection is actually going through the edge server. It's not going through mobile's host address, which is the Wi-Fi address, or the mobile's NAT address. So that was the key takeaway from this one, that it's actually going through the edge external NIC, and not actually the mediation talking with the edge's public IP. Since we're running short of time, I think we'll skip the Wireshark.
Yeah.
For this
Okay.
one. Yeah. Scenario 5.
Okay. So any questions so far?
Just a quick question regarding
Yeah.
You mentioned that there was a bug. Is there any way or any site that we can go to determine what bugs are current, what bugs have been resolved regarding the phone?
So with every cumulative update, we actually publish out, like what has been fixed. We don't really actually have like a known bugs, or we don't advertise what's a known bug to us right now, unless it's actually affecting like hundreds of customers. We don't usually publish a KB. We try to publish a KB for every critical issue that we think is out there, and it would actually help us bring down the customer calls. So it really depends. I mean, yeah, we try to take a judgment call there and try to publish a KB. But there's nothing that is like officially saying that if QA finds a bug, we'll have a KB. Yeah, I mean, that's because bugs and feature requests and fixing is part of a product. So yeah, but we try our best to publish KBs on known issues. Yeah. Or blog it.
Okay, I'll quickly go through the scenario 5 and 6 because we are running pretty short of time. So scenario 5 is actually with the voicemail, which is on the cloud on O365. So this would be a working scenario where mobile users trying to call another user, and the user so happens to be busy or probably do not disturb, and actually the call eventually drops into the voicemail platform. Okay, so once again, this would be the signaling. So you have your Lync mobile, your UCWA, your front end, your edge, your remote Lync user, as well as the online. So whether it's a remote Lync user or internal, for this case, it will be actually a Lync user per se. So traffic works quite similarly. So as you know that a peer-to-peer call will be first attempt to be established, else it will be actually routed through edge. And if the user is actually not around, or probably does not, he's not able to actually pick up the call, it cancelled, and you will actually see a new SIP invite that is actually trying to call to the online. Okay.
So one thing that actually the server does here is the front end keeps track of how many seconds have elapsed before the user actually picks up the call. So if it's saying 20 seconds, then the front end knows the user hasn't picked up the call in 20 seconds. So that's why you see the cancel after 20 seconds there. And then based on what the configuration is, the front end will send the call out to online.
Okay, I think we'll skip the logs. Do you want to go through the logs?
So the only thing that would be seen in the logs is as soon as the cancel is sent out, the front end will again ship out a new invite to the edge, and the edge will send it out to the Lync online, because online is still behind another edge. So the only thing, yeah, but I think we are running short of time, so we'll skip the logs for this
from
one.
an illustration purpose, I think this is what I'll do. Let's just pull all the diagrams out. So what happened is there will be an invite from the mobile. So this will be the topology that we have. You are sitting behind a firewall, and there is an edge server in there. So the first attempt to actually call the voicemail or the server, but of course this is actually not permitted, and you will actually need to go through the edge. So the invite actually works this way through the edge, and the user on the other hand, okay, receives a 183 signal sending back to the Lync mobile. So apparently the user may not be available for next 20 seconds, and you actually send a cancel. So signal, oops, went a bit too fast. So there will be a signal sending a cancel from the front end, and this is where you actually make the call to the online at 0365. So from the logs, you will be actually able to see the first attempt calling to a private IP, which is not allowed to, or even through the NAT IP, which is no, it will not work as well. So, oops.
So as we can see, the is publishing, is advertising its host address, it's advertising its NATed address, as well as it's telling that, I'm behind the edge, so we can do the relay as well. So those three dotted lines were actually to tell the mobile user, you can reach me through either of these three.
And you can actually see it from the OCS logger as well. Yeah. Okay. So for media candidates, this will eventually fail, because once it's advertised and private to private is actually not supported, as well as the NATed IP address. So your final candidate will actually go through the edge, okay? And this is how you actually establish your call with the role. So key points to actually take away, it will be that when you actually look at your log files, need not to be afraid that the first two attempts will eventually fail, because private to private, as you know, all 365 are secured, and your Lync mobile will be not able to actually establish a peer-to-peer. So your end state should be a public IP, okay, a public IP. Any questions? Sorry, I'm going a little bit fast on this because we are running out of time. Any questions so far? If not, probably we'll move on to scenario 6, and we'll bring up, if there's any questions, we'll take it offline. So in scenario round number 6, this was a POC that I've actually conducted back in last year, I think about August, once the Lync mobile updates was actually released for one of my customers, and they are actually a local bank. Okay, so here's the scenario. It was a proof of concept to test out Lync mobile. It will be a wireless network on the different VLAN. I believe a lot of customers or a lot of partners outside will eventually have such a scenario where your mobile actually sits outside of the normal production VLAN. And because this is a POC environment, the VLAN is actually restricted using split brain DNS. And the problem here that we were facing was the users from within the corporate network behind the firewall are unable to actually make a calls to users who are actually sitting outside of the corporate network, for example, from the home. Okay? So this is what we will actually get. So once the Lync client actually calls to the Lync mobile, we will actually see that, well, there is a call that is trying to initiate, but when you try to pick up, the call eventually fails. And from the components perspective, this is where the signal actually falls. Okay, so H was not actually able to return, and there you go. Your Lync mobile was not actually able to be established. And from illustration perspective, let me just pull out all of this. So we have 3 different VLANs for simplicity. We have the production VLAN, where all your front end, your back end are all actually sitting. You have your Lync desktop clients, and you have your Lync mobile, which is on separate VLANs. And then you also will have the remote user sitting behind, outside of the corporate firewall. And calls between the Lync mobile and the Lync users, okay, within the corporate network are absolutely fine. Users are not actually facing any issues. Okay, so sign in through the firewall, opening up port 443 HTTPS seems all right. But when there is a call that we have actually attempt to make to the Lync users, which is outside of the remote network, did not work. Okay, and looking back at the log files, we have actually enabled logs from the OCS logger, the front end, the edge, as well as the Lync mobile. And this is what we've got. So if you notice that there is a record over here, okay, the internet edge, the destination is out from the edge, because this was actually a local bank. Basically, the customer did not actually allow us to actually open ports directly between the VLAN to the firewall, and all traffic must be forced through the edge. And you notice that there is a failed to start audio stream, okay, that's been gathered over here. And or was actually running an Android device during that moment, and there was a reason down there that you can see. Okay. So this is what basically you have in terms of the entire log files. So let me just put a zoom. Okay. We are actually trying to call a remote user through the IP address of a public IP of 1.1.5, okay, which is my audio and video IP, okay, and there's a local, okay, and the remote site IP is actually running on, my client IP is actually holding on a .50 IP. So let me go through next. So gathering logs from the Lync mobile, these were the error that we actually noticed. So if you notice line number 2, failed with SDB no media and aborting the call. So we noticed that the Lync client was not actually able to actually make the establishment with the XSH and through the remote users, and that resulted the failure of the call. So what we did was we have actually went another step ahead to actually confirm that the firewall ports are actually not open from the VLAN perspective by gathering debug logs on the firewall. So that shows that the firewall is actually restricted, okay, for clients to actually even talk to the DMZ zone. So once we have actually opened up the media streams, okay, the SDP, the UDP, the TCPs and the UDPs, the clients was actually able to actually make the call. So do take note that if you are running actually on a POC environment, especially on a separate VLAN, these are things to take note, because new provision, new VLAN, new policies needs to be implemented, and being probably a small testing lab environment, the customers may not be aware. Okay, so there will be a little bit more of topics. I'll hand this back to Kaushal.
Yes, thanks, James. For mobile media, what we have seen is there are some scenarios that are actually unique with mobile client, because with mobility, the user is, of course, it's mobile, as against a Lync desktop scenario where the user is sitting in the same network or it's not moving, not changing Wi-Fi. With mobile, the user is in a different, it's in multiple networks. It's in Wi-Fi, 3G, as well as a PSTN callback, at the same time. So the limitation that we have is like when changing networks, the call currently doesn't have like seamless failover or seamless transition. So if you are changing from Wi-Fi and if you are leaving the building, the call will actually drop. We don't have that. We are tracking that through an internal feedback item. So if you have any feedback around that, if you have, if you are hearing a lot of complaints from your end users regarding this type of changing network type of scenario and the call drops, let your account team know or let your TAM know. and will actually add the customers to the item. We need like more feedback on this, so that way we can have a robust solution right now for changing networks for mobile. So just to recap, so the objective here, with this session was to isolate the scenario, isolate what your user is saying, and understand the scenario thoroughly, come up with the right thought processes, understand the call flows, the call paths, understand the ICE negotiation, the media connectivity checks, and the end goal is actually troubleshoot faster. That's our main objective, and we try to do it through through the 6 scenarios. So, any questions? And should be it.
Just in time.
We have another session actually, Network W401 by Thomas Bender and Brian Nice, that will go deeper into the ICE negotiation, independent of what clients you are using. So that's going to focus just on ICE negotiation, and it's again at a 400 level session. It's today late in the day. So I would encourage you to attend it.
Thank you.
Thank you.